Today we're talking about clouds and cloud formation. And I thought what better way to talk about cloud formation than to make a cloud. So that's what we're going to do. We're going to try to make a cloud in a bottle. Let's do a quick review before we start though. We've already had our lessons on air pressure and on humidity. Whenever it's high pressure, we learned that air is falling. And when air falls, it warms. And the warmer the air is, the more water vapor it can have. Low pressure is the opposite. When it's low pressure, air is rising. And as air rises in the troposphere, it normally gets cooler. The colder the air is, the less water vapor it can hold. And it's more likely for the water vapor to condense, making clouds and rain. Okay? So that's why high pressure, the air is falling, it's usually clear and sunny weather. When it's low pressure, the air is rising, it's going to be cloudy and rain. Because as the air rises, it cools and it can't hold as much moisture. Okay, so that's a little bit of background. Let's try to make our cloud. Like I said, we're going to make it in a bottle. So I have a glass bottle and I painted the back of it black just to make it easier to see the cloud since clouds are white. Well, what do we need to form a cloud? We need water vapor, obviously. So, let me get some water vapor. Put a little bit of water in, that should be enough. Shake it around a little bit. Okay, we have plenty of water vapor in there. What else do we need? Well, remember, as the air rises, it gets cooler. So I could use cold temperature, or I could use that low pressure. Easiest thing for me to use, low pressure. I have a vacuum pump here. So let's try it. Put the stopper in, turn on the vacuum pump to suck the air out and make low pressure. Hopefully we'll see a cloud. I don't see anything. So what's going wrong? What's going wrong is we're missing something. Water doesn't like to condense onto itself. We need something for the water vapor to condense onto. What can we use? We need a small solid particle of something. I think the easiest thing for us to use is smoke. So I have a match. Let me light it. Get it burned a little bit. Drop it in. Cap it up. So I should have a little bit of smoke in here. Now I can't really see the smoke, but hopefully there's some in there. Now hopefully if I get my low pressure, that water vapor that's inside the jar will have something to condense onto. Let's try it again. Okay. Now I get my cloud. You should be able to see that. When I get rid of the low pressure, cloud goes away. Get my cloud goes away. And we'll wrap a little closer. Low pressure, my cloud. High pressure, the cloud goes away. Okay, so whenever it was low pressure, the cloud formed. When I took away that low pressure, the water vapor again was released back into the air. Because again, it's not cool enough. The air can hold moisture. So I use smoke as a condensation nuclei. That works in real life too. After forest fires, lots of times there might be storms. Could be pollution, could be salt from the ocean. The winds pick up little bits of salt. They even found plankton in some in Oklahoma, and I'll mention that when we get to the notes. That's my basic little thing about clouds. So we need not just two things, not just water vapor and low pressure. We need some kind of condensation nuclei.
You just saw in my demonstration how to form clouds. Now we're going to see how it works in real life. So we'll start with this first picture. You see the sun heats the ground. As the ground heats, it evaporates water, so water evaporates into the air. The air gets warm, warm air rises. As it rises up in the troposphere, the temperature of the air cools. And remember, cooler air can hold less water vapor. So the water vapor will condense out and form clouds. We look at this picture and it has some temperatures on there for reference. So let's say the surface temperature of the air is 78 degrees, but the dew point is 58 degrees. Remember we learned about that when we talked about humidity. If you raise this parcel of air up, the dew point is going to stay the same because it has the same amount of water vapor in the air. The temperature of the air, though, is going to get colder. So now it's 68 degrees. Okay, it's more humid. Keep raising the air up. Eventually, you're going to get to an altitude when the temperature of the air is equal to the dew point temperature. When that happens, the water vapor is going to condense, and you're going to get clouds. That's why when you see clouds, lots of times you see the clouds have a very flat bottom. All the clouds start at the same altitude. Okay, that was the altitude where the temperature was equal to the dew point. Well, what if the dew point was a really high temperature? Then, as the air raises, maybe you're going to form your cloud at a lower level because the temperature is going to reach the dew point earlier. Well, what if the air is really dry and it has a really low dew point? Well, then maybe the air is going to rise up, 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 and it's going to go really high before it gets cool enough to condense. Maybe it's so low of a dew point that the air never rises far enough and you don't get any clouds. Okay, that can happen too. So this is going to be a review of what we just learned in my demonstration. So clouds form when water vapor in the air condenses to form liquid water or ice crystals. So to form clouds, there must be three things. Remember, we went over them. We have to have water vapor, obviously. We have to have that low pressure or cold temperatures. We need that air to rise, and we need it to be colder because cold air can't hold as much water vapor. Then the third thing we need are condensation nuclei. Remember, we used smoke in the demonstration. Condensation nuclei are just small solid particles that water vapor can condense onto. And when we're talking about small, we mean small. So this picture shows the size of an average raindrop, about 2 millimeters diameter. Average cloud droplet, about 0.02 millimeters. Condensation nucleus size, though, 0.0002 millimeters. These are tiny, tiny, tiny things. So imagine every cloud droplet and every rain droplet has a piece of something in it, has a condensation nuclei in it, or condensation nucleus in it. Now, what are some examples? You saw in mine, smoke is good. The most common one is salt from the oceans. When the wind blows the waves up, some of the water evaporates and that salt, so tiny salt crystals are thrown into the air. Pollution could work. Pollen could work. Anything that's really small and solid. University of Oklahoma did a test to find out what some of the condensation nuclei were in some of the big thunderstorms that went over the state of Oklahoma and caused these huge thunderstorms and rain. So they went up there with the airplane, they scooped up some cloud, they brought it back down, and they looked at what the condensation nuclei were. And they were surprised because they found that they were frozen plankton. Okay, so plankton, a little sea creature, it was little frozen plankton were the condensation nuclei. They must have come all the way from the ocean, were blown up by the wind, got caught in an updraft, and went all the way up into the atmosphere, froze, and then they acted as condensation nuclei. Other things, people are trying to do cloud seeding. You might have heard of that. We're trying to get it to rain on purpose, where they fly into a cloud in an airplane, and then they release some kind of a substance to get the clouds to rain. Okay, they're adding condensation nuclei, trying to get the clouds to rain. Okay. So that's how clouds form. Now we're just going to finish up with clouds, and we're going to talk about naming clouds. And we're going to do the very basics, and that'll cover probably 90% or more than 90% of the clouds. So if you look outside after we go through this, you're probably going to be able to identify the cloud. said there are some that we're not going to cover, but this is going to get the majority. So when we're naming clouds, we're naming them or classifying them according to two things: shape and altitude. There are three main shapes, and then there are three main altitudes. When we construct these, we're going to think of this as like the base, and then this is going to be a prefix. Let's get our shapes first, though. What shape does cirrus mean? Cirrus means wispy. So cirrus clouds are a wispy shape. So maybe if you draw a little picture, it's kind of like these wispy. Some people say like horsetails. Little wispy shape. Cumulus. Those are the puffy ones. Okay, really, it means vertically developed. That's a little bit more to write, but vertically developed or puffy. So maybe on my little picture, okay, a little more vertically developed or puffy clouds. Stratus clouds, those are layered clouds. So think of them as layers or maybe blankets. Okay, so I'm just going to put some layers like that. Okay, they're layered clouds. So those are the three main shapes of clouds. Now we need to get the altitudes. Cirro altitude means high. Alto is a medium altitude. Think of it kind of like music. Strato, that's low clouds. So now, to get our cloud names, we can just combine them. Okay, our prefixes with our base. So if I say a cirrocumulus cloud, well, that would be a high-level puffy cloud. What about an altostratus cloud? That would be a medium-level layered cloud. So that's all you're doing to combine your names. Now, there is a little bit, a couple that are kind of different. How about a high-level wispy cloud? Cirrus. Well, that sounds kind of stupid, cirrus. So what we just say is cirrus for those. The same thing is true for this low-level layered clouds. Stratostratus, that's kind of stupid. We just say stratus. Okay? But that's how you make them up. If a cloud has precipitation, then it has nimbo in it. Okay, so precipitation, nimbo. And it could be a prefix or the base. So I could have a low-level layered cloud that's raining. That would be a nimbostratus. Or I could have a vertically developed cloud that's raining, a thunderstorm. That would be a cumulonimbus. So you're just putting these together. So let's look at some pictures of them. Here are some cirrus clouds. Okay, these are the wispy ones. They are really high level, made of ice crystals. The wispy ones, cirrus. Cumulus, they're the puffy ones, the ones with vertical development. Lots of times they're going through more than just one layer. Okay, vertically developed, caused by updrafts, taking the air up and up and up, getting into cooler levels to get condensation. Stratus, these are the layered clouds, kind of look like blankets covering the sky. So the whole sky is going to be covered usually by the stratus clouds. Here's a chart. So the main ones that we talked about are these ones. So we see the cirrostratus. They're high-level wispy clouds. See high level about 16,000 to 50,000 feet. Cirrocumulus would be high-level puffy clouds. And then we have just regular cirrus clouds. Virga is just rain or snow that evaporates before it hits the ground. So not a cloud type for Virga. Altos, we have altostratus, middle level layered, altocumulus, middle level puffy or vertical developed, and then altocumulus, Oh, so altocumulus again, this one has Virgo with it. Then we have our stratus, okay, our low-level layered cloud. Our stratocumulus, our low-level puffy cloud. We have our precipitation one, our nimbostratus, and then over here we have our big cumulonimbus. So you see this idea of cumulus is vertically developed. It's covering all the layers of the atmosphere. It's very vertically developed. Okay, you get bad storms with these big updrafts. Some more pictures. Here is a cirrostratus, so a high-level layered cloud. Nimbostratus, layered cloud with rain. A big cumulonimbus cloud. Okay, that vertically developed. You have thunderstorms, maybe tornadoes and hail and stuff in here. Okay, now it's your turn. What are some of these? How about this one? Okay, they look like little puffs. So it's going to be a cumulus. And what altitude? Well, maybe an alto. It's probably an altocumulus. How about this one here? Well, it's covering pretty much the whole sky with a layer of clouds, so it's going to be a stratus of some sort. Well, what altitude is it? Yeah, maybe it's a low level. Maybe it's just a regular stratus. Maybe an alto stratus. Probably still a stratus. This one here, kind of hard to see, but all these things are little puffs, tiny little puffs. So that is very high level puffy. So a cirrocumulus cloud. This one here, look at all these little wisps of ice crystals. Okay, that's a cirrus, the cirrocirrus we just call cirrus clouds. Very high level wispy clouds made of ice. How about that? Look at the little tornado coming out of there. A little wall cloud you're seeing. Huge vertically development with rain. Cumulonimbus. Another cumulonimbus. Hurricanes, remember, are made of cumulonimbus clouds. These are just some other ones. Like I said, we're learning the main ones. There are some other ones that we're not learning, some special ones. This is kind of neat, called a lenticular cloud. When the air is forced up a mountain, so if the wind's blowing, the air gets forced up a mountain, it's going to get colder, so it's going to condense. You get these little spaceshipy type clouds that might form, lenticular clouds. These are mammatus clouds. This is the bottom of a cumulonimbus cloud. Basically, when you see this, it means there are really strong updrafts and there's like hail that is trying to fall out of these things, but the updrafts push them up. So these are kind of scary clouds. Really, really bad weather is associated with those clouds. And that's it for our cloud types and our cloud formation.